Okay, so 5.5 is solving radical equations. So what we're expecting is equations, we're expecting things with equal signs. Radicals, we're expecting radicals. And we're going to solve them. So we're going to go through, now we're going to talk about how do you deal with it. How do you get it down to just like x equals at the very end. So that's what we're going to kind of go through here. Now, it's a lot like just regular algebra in here that we're going to use a lot of the same steps. Our first thing is that we're always going to try to isolate the radical. Like, you know how we always try to get x by itself? We're going to try to get the radical all by itself. So like whatever is underneath the radical can stay underneath it, but everything else needs to be moved away. So we have just the radical by itself. And then we're going to raise both sides of the equation to the power equal to the index of the radical. So what that means there is like, if I've got a square root, I'm going to raise both sides to the second power. If I've got a third root, I'm going to raise both sides to the third power. Because raising it to the second power will get rid of a square root. Raising it to the third power will get rid of third root. And so on and so on. And then we're just going to simplify and solve. So we're going to go through these. Remember that when we do these, our first step is going to be to get the radical by itself. And when I say the radical, I mean that this is going to be, whatever is underneath there should be all by itself. Like we're going to keep the radical all by itself there. But everything that's not in the radical, we need to get to the other side. So what's the first thing that I should try to get to the other side?
1.
The 2. There's a 2, right? Because the radical, everything in the radical is going to stay. But the 2, it's 2 times that radical. So how do I get rid of that 2? We're going to divide by 2.
So the square root of x plus 1 is equal to 7.
Good. So we've got the square root of x plus 1 is equal to 7. Now, that is a square root. And to get rid of a square root, all we need, bless you, notice that there's nothing else with the radical. To get rid of a square root, all we need to do is square it. Because squaring it cancels out with that index there. Since that index is a 2, that secret 2 in there, this radical will be gone and that 2 will be gone, leaving only x plus 1 on the side. However, we also need to square the other side as well. If you square one side, you have to square the other side. So we get x plus 1 is equal to 49. Where am I going from there?
Subtract 1.
Subtract 1, subtract 1. And x is equal to 48. Done and done. It's a little easier than what we've done before, right? And that's what we're going to see today. Somebody said no? This was harder than what we did yesterday?
I think yesterday was easier.
I think the only thing that should feel like it's maybe new to you is that these radicals here, whatever the index is, are canceling out with that exponent.
That's a given though.
Oh.
You know?
So that won't be too hard. We're going to do that same step over and over again, so you'll get that. Don't worry. Let's try B. What's the very first thing I should do? Right, because again, this is what we are trying to get all by itself. Like this should be the last thing left over there. So we're going to divide by 5 because that is 5 times the cube root of 4x plus 3. So we're going to divide by 5. That will cancel out these 5s. But I'm also going to divide by 5 over here. And I get the cube root of 4x plus 3 is equal to 15 divided by 5, which is 3. Okay, so now squaring it will not get rid of that cube root. But what will? Cubing it. Whatever the index is, notice here, I had to do that same thing here to get rid of it. Before we had a 2, so we squared it. Here we have a 3, so we're cubing it. And what it leaves us with is 4x plus 3. But since you cubed one side, you had to cube the other side as well. So 3 cubed ends up being what? 27. 3 times 3 times 3. 3 times 3 is 9 times another 3 is 27. Where am I going from there? Subtract 3. Just like we've always done algebra now, 4x is equal to 24. And from there? Divide by 4. Divide by 4.
So the exponents cancel?
The exponent cancels out with the index. Okay, so there's B. We're going to move down. These first ones are fairly straightforward. Okay, now just take a look what we've got here before you start making a decision because we're just going to use algebra the same way we always have. Although this one is slightly different than the last two. It's just slightly, not major. What's different about this one? Yeah, we're going to subtract first because this is 4 plus that radical. So we're going to subtract 4 and subtract 4. And then we're left with the square root, x minus 1 is equal to 1. Where am I going from there?
I have a question.
Yes, ma'am.
Why can't you just look at it and be like, okay, 2, like
What do you mean?
x equals 2 minus 1, which equals 1?
And then 1. So what you're saying is that like by looking at it, you could just figure out the number.
Yeah.
So because we're just starting off, the numbers start off kind of easy like that.
Mm-hmm.
But I promise you where it's going won't be very easy. So we need a strategy that will work every time. That you're right. You could probably, it's much easier to be like, oh yeah, I could just look at this and figure out that answer. But as we go on, they're going to get to the point where they're not easily seen. Like you won't be able to easily figure out what the number is. So that's why we're using the simple ones first to kind of teach the process. So what's my next step?
You're going to do the square on top.
Okay, so we're going to square both sides. And then what do I write on the next line?
You're going to cross off the squares, and it's going to be x minus 1.
Is equal to 1 squared, which is?
1.
Okay.
And then minus plus 1, sorry. And that equals 0. And then 2.
Now let's say that we're not sure and I want to check this. I could go through and I could re-plug it back in just to check to verify that it works. We could go 4 plus the square root of minus 1 is equal to 5. So we get 4 plus 2 minus 1 is equal to 5. The square root of 1 is 1. And we would get 5 equals 5. So if we needed to check it, 5 is equal to 5. That is a true statement. That works out. Yes, sir?
So should you always then, like, before you're going to cancel out the square roots, move all numbers that are not like associated with the square root to the other side?
Exactly. So our first step is to isolate the radical, which means that I shouldn't be squaring until this is all by itself. Yes, sir?
And if there's a number like outside of the square root, like 2, if there's 2 square root of x minus 1, would you also square that too on the outside?
Hang on. So you're saying what? 2 square root of what?
Like that same problem. Would you also square that too on the outside?
I'm sorry, when you say the 2 on the outside, I'm not sure which 2 on the outside.
Like 2 square root of x minus 1, and you put in parentheses square to cancel out that radical. Would you also...
You mean like this, right?
Yes.
So you wouldn't even start squaring until that 2 is gone.
Unless you divide it.
Right, you got to get rid of that 2 first before you should be squaring.
Okay, thank you.
Talk to me. What should we do first?
Minus 2.
I hear some debate. What are our thoughts?
Is there a number? Oh, you just multiply by 3.
Multiply it by 3, like this?
You did the
Right. So we're going to cube it. We're going to take it to the third power because notice that the radical is all by itself. There's nothing else over there with it. It's already by itself. There's nothing to move away. There's nothing being added, subtracted, multiplied, divided over there. So what we're going to do is just start by cubing it because cubing it gets rid of the cube root. But whatever I do to one side, I have to do to the other. So we get 3x minus 4 is equal to 2 cubed. And 2 cubed is what? 8. 2 times 2 times 2. A lot of times people will accidentally write 6 because it looks like 2 times 3. Just be careful with that. It's easy to make that mistake, and then your answer is going to be off. What's my next step?
plus 4.
Plus 4, and we get 3x is equal to 12. Divided by 3.
X equals 4.
Fantastic.
That's easy.
Yes, sir.
We have a question. Is there a 1 in front of the radical? Like, is there
Here, technically, yeah.
Yeah.
But if you divide it by 1, it really wouldn't change anything.
Oh, I know.
Ooh, there was like a thought. You had a thought there, and you were processing it.
How'd you get 8?
How did I get 8?
Yeah.
Because this was 2 cubed. 2 times 2 times 2. So 2 times 2 times 2. 2 times 2 is 4. Times another 2 is 8. All right, let's go on to E. We'll make it all the way down to seeing where I want to stop.
How much does it go all the way up to 12?
Yeah, I just want to make sure I give you enough skills to get you through 12. So, okay. All right, so let's do this one. What are we doing first? Divide by 6. Divide by 6. Okay. So what am I going to write on the next line?
X plus 10. That's 7.
Like that? By the way, I'm writing whatever anyone tells me, so if there's something wrong, you need to call me out.
This is up to 12, right?
So 16.
That like dyslexia or something?
Okay, but we have a problem here. I realize you guys are debating over the homework, but right now there's a problem with the notes. What's going on here?
Minus 10.
We've done something. We haven't dealt with the square root yet, so we can't just drop that. We still have that square root to deal with.
So then square root by 2. So then square by 2.
Okay, so we're going to square it. Because squaring something gets rid of a square root, but then we have to square the other side as well. So what's the next line going to look like? Yeah, this gets rid of that. So those two things cancel each other out. So whenever the whole purpose of squaring them was to get rid of a square root. Okay, I'm sorry. Next.
Minus 10.
39.
Yes, sir.
Yes, sir.
I love that so much. I don't know why I love that sound so much. TikTok is like, I know, like I shouldn't love TikTok. I realize I should probably say something about there's better things to do with your life, but I just love TikTok so much. I should be like a model for you guys and be like, guys, listen, go be doctors and lawyers, but I'm like,
Yes, sir. Yes,
yes, sir.
Yes, sir.
Instead of like it's like TikTok.
Go for it.
So you have to put it by 2.
What do you mean by put it by 2?
Like put the exponent 2.
Okay, so we're gonna square it like that.
Yeah.
Okay,
And then you put 2x minus 1. You have to do it to the 3 too.
good.
And then 2x minus 1 equals 9. And then you add 1 to the next one, and then add 1 to the other side. Then you get 2x equals 10. And then you divide both by 2, and then you get x.
Beautiful. Hey. About that. All right, let's finish this up. We've got this one. Now be very careful. There's a lot going on here.
Well, you add the 1.
Good. Let's add the 1 because look, so where your radical is, I know that some people are going to be like, wait, why did you do this? But look where the radical is. The radical is just there. So we're going to add the 1 to the other side over here.
Do that first, though.
Well, because if you do division, let's say we divide both sides. It's a good question. Like when you're doing, like let's say that, let me do this. Let's go back to if I had x, 2x plus 1 equals 11, okay? Let's say, forget about what we just did. If I was going to do this, what is the very first thing you do?
Minus 1.
Right, you would get the subtraction dealt with first before you did the multiplication division. So that's the same thing that we're doing here. I need to get that negative 1 to the other side, so I'm going to go plus 1, plus 1. So disregard this. This was just illustrating how we do it. So now we've got 2 times the cube root of x is equal to 4. What's my...
That's what we've been doing. That's the basic.
Divide by
Yep.
2 on both sides.
Divide by 2 on both sides.
And then,
And now we've got the
Cube root on them all.
yes.
cube root them, so like this.
So 2 to the...
No. Wait, what's the...
No. Parentheses.
Parentheses.
Okay, so we just say cubing. We're cubing it like that. Or if you prefer, like to the third power. So,
And to...
And then you cancel it.
okay.
And then you make the other one 12.
8.
I was like, he's just messing with me.
I did the rest of it.
Yep. We're going to do this one over again just because I know that we were like, wait, why did that happen? So I'm just going to... Now you remember? Oh, fiddlesticks. Okay.
Oh, wow.
Tortinos, Tortinos.
I'm gonna go home and make that TikTok now.
Oh, you'll be my new favorite. You'll be the only person I follow. Okay. So here's where we run into a different scenario here. And where we go, wait a minute, what the heck would I do here? Because what is the problem? Like take a minute and think about what you would do, and then you're going to run into a problem.
Divide by
You're gonna
5.
divide by 5.
Okay, so let's see what happens when we divide by 5.
You can't divide the other side.
You just
Or can you? Would it be like
no. You can
7x?
located, so you can't.
One's an outside number, one's an inside number. Those two aren't going to. So here's what would happen. I'm just playing what if here. This isn't. You don't have to write this down because this is not what we're actually going to do. But I'm just playing what if we did that. What would happen? We would end up here. I don't feel like I'm in a better place now. Do you?
No.
It feels like it's like a really weird place. Yes, ma'am.
Don't you have to find the square root of 35 first?
I don't know the square root of 35.
Wouldn't it be 7x? Not.
So 35 and that 5 cannot cancel out because one is an outside number and one's an inside number. She's like, what about the 35 and the 5? But let me show you what we can do. And here is what happens. This is gonna happen every single time that we have two radicals. Like if we have two radicals, we're going to make sure they're on opposite sides. These are on opposite sides. One's on the left, one's on the right. Now, how did we get rid of square roots a moment ago? We squared them. So watch what happens when I square both sides. The left side is super easy, right? The left side, we dealt with that. What is the left side going to become? It just becomes 35x. You are 100% right. Now, here's the thing. You've dealt with this before. What is going to, so I'm going to deal with this in two parts. This 2 is going to be applied to this square root and the 5. So let's deal with it with the square root first. In the square root, what's going to happen when this 2 hits that square root? It's going to disappear and just be x plus 2. Now you might be like, why did you leave it in parentheses? Because there's also a 5 I have to deal with. And that 5 gets squared as well.
25.
Perfect. So 35x is equal to 25 times x plus 2.
Why did x plus 2 say the same?
It didn't stay the same. We dropped the radical.
Oh, okay.
Yeah, we lost the radical. So we are going to distribute now, and we get 35x is equal to 25x plus 50. Next step.
Subtract 25.
Oh, no, wait,
Subtract
sorry,
25 and then it's
35 and 25.
Yeah.
Okay, so we are going to subtract 25x, and we get 10x is equal to 50.
You divide by 10.
Divide by 10, and x is equal to?
5.
So when we have those, if you have two radicals, first of all, make sure they're on different sides because it can be really stressful when they're on the same side and you're like, well, what do I do if they're both on the same side? We're just going to move them to opposite sides and square both sides. Now notice what happened here. The only thing that was a little bit weird was like, well, what do I do with this 5 out front? Well, the 5 also gets squared. The 5 got squared as well. The square root of x plus 2 got squared and it made the radical go away, but the 5 also got the square because that was something being squared too. I needed to square everything on the right, not just one thing. So that's what we're going to do in almost every situation where we've got, yep.
Two radicals that equal each other.
He didn't actually throw the coin at me, he tried to, and it actually landed out in the parking lot somewhere. That's how close it came. All right. Let's do B here.
Yeah.
Talk to me. Okay, the coin is causing a problem now. Let's keep going. Do what?
Square root of both sides.
Not square root, but square. Be very careful.
Yeah, I mean square.
All right, what do I have after I'm done squaring?
We're gonna have 8x plus 6 equals 9
I'm going to just do this. I know you're doing this in your head, but I'm going to do that just so we can see it.
and x.
Okay, and then,
Parentheses x.
good. So this squared gets applied to both of those. So it becomes 3 squared. And when we square the square root of x, it just becomes x.
Yeah. Now we're gonna do 8x plus 6 equals 9x. And then we're gonna do minus
that, yeah.
Oh, I'm sorry.
Okay,
It's okay.
Yes.
If it was negative, then we
I don't understand the 3 squared x.
It's 3 squared times x. What is 3 squared?
9.
And then what's 9 times x?
3x.
9x.
If you just drew. Oh, that's what you did.
Yeah, that squared had to be applied to both of those things there. Gabby's question, I think, was something like this. Like, what if I had something like this, yeah?
Yeah, and then you would have to divide it by -1.
Or multiply it by -1, either one.
It
No.
would never be negative x either way.
Well, you could have, if you had decided to subtract 9x instead of 8x, then you would have ended up, it'll still end up as the same answer.
Negative x.
But you did it in the same way that I would have done it. I would have said, I don't want my x's to become negative. That's an extra step for me. I always try to make it so my x's end up positive. If I can do that, I always try it. So you went the same direction I would go.
But let's say it ends up, like, that wouldn't be the answer, negative x.
Correct. You never leave it like that. You would either divide or multiply by -1. I know you said divide, so I'll do it that way. It would go like this, and then it would become x equals -6. I just wrote it like that way. This is not the answer to that. I'm just showing you how you would deal with that situation. So that is not the answer to this. That's just a what if. Okay, so that is that one. Yes, sir. People are going to listen to this video and be like, those kids are so respectful. They say yes, sir, to everything he says. I'll be like, I don't think you get it.
Are you recording this?
Yeah. Oh, I record the
Wait,
It's
so
always our
this
period,
is gonna
though.
be on YouTube. We can go back. It's always our period.
Yes, yeah. It's usually whoever comes first. That's usually it. Unless like I think one of the lessons was much better than the other, then I put that one up.
The best one was the higher.
Okay, so you cube everything.
Okay, outstanding. I love it. She said cube everything because this is not the square root, this is the cube root, so we need to cube everything. Talk to me about the left-hand side.
It cancels out the square root
X plus
or the cube root.
Good. X plus 6 is equal to
2 to the third.
2 to the third.
Then just x minus 1.
Good. Now, I'm putting the x minus 1 in parentheses. And here's why. Because it was 2 times this. It still needs to stay 2 times that. But we lost that this got rid of that.
But isn't it x minus 1 cubed as well?
No, because the cubed we already dealt with. It canceled out with that. So we already did, like what we did there was we took the cube root of x minus 1 and we cubed it. And then this canceled out with that, leaving us just x minus 1. So now we're here.
So 2 cubed is 9. And then we distribute.
Are you messing me? Are you messing with me now?
Oh,
X. So 2 cubed is what?
8.
Okay, so it's 37. No, I'm just kidding. It's 8.
And I would distribute it.
Distribute, and we get x plus 6 is equal to 8x minus 8. Okie doke. Talk to me.
Minus.
I would add 6 to the other side.
Okay.
Minus x.
I would minus x first.
Okay, let's do our x's then. I heard a lot of talk of x's, so we got 6 is equal to 7x minus 8.
Now
Add 8
minus.
to both sides.
Yeah.
That becomes
Can you please send Gabrielle Ashkenazi to Student Services?
She's on her way. 6 and 8. What does that equal?
2 equals x.
14 is equal to 7x
Divide by 7.
divided by 7. And as Christian just said, x is equal to 2. Gabby, we're only doing one more, and it's just like that.
Okay.
We have one more problem. Let's finish it up.
Then you have to play the song.
It's really not going to be as funny unless you see the show. I think it's actually going to ruin it for you. So my recommendation is to actually watch it. So let's finish this up. Now remember, what is our first goal? I told you at the very beginning. What are we trying to get by itself? The radical. So our goal, no matter what you're about to tell me to do, is to get the radical by itself first before you do any squaring, any cubing.
Divide.
Minus what? Minus 3x. That kind of like peels away from the outside. So we've got negative 5 times the square root of x. Now remember, we're going to subtract 3x from both sides. So we get is equal to 2 minus 3x. Yes.
You're allowed to just do minus 3 Oh, you.
I did, yep. Bless you.
Wait, then why didn't you add 5 to 2? Okay, it's part of this.
That's negative 5 times the square root of x, and we haven't dealt with it yet. So what are we doing next?
Square.
Dividing?
Well,
Uh,
Just kidding.
I'll explain some.
Can you do like time?
So
the second power?
again, there's some side conversation going on, but what is our goal to do what? Remember I told you what is our goal every time?
Radical.
Get the radical by itself. Is the radical by itself?
No.
So what are we going to do?
Square.
And I know that some people don't want to do that because they kind of see where this is going and they're like, oh, I don't want to do that. You go, but that's where this is going. So we've got, you may have, it's just a bunch of people are shooting stuff out all at the same time. So we've got 2 minus 3x over 5.
Isn't it negative 1?
What do we want to do now?
Isn't it a negative?
Square root.
Oh yeah, it's a negative 5, sorry.
I mean root.
I mean root, so square, what are we doing? Square rooting or squaring? So we're going to square both sides.
X equals 4.
Whoa, people are scaring me with how quickly they're doing this because I go, that means they're not sure about what to do. So check this out. Here's the step that people are going to miss. I'm going to show you exactly what I should be seeing. Remember, that applies to both the top and bottom, right?
Oh, so 25. 4 minus.
Don't tell me 4 plus 9x, because that is not how we square this. So here's the biggest mistake, and I'm going to tell you right now, watch what I'm doing. What I'm doing is not correct from here on out, okay? So don't write what I'm about to do down because this is incorrect. A lot of people will take this right there and they will do this. They'll go, well, if I square 2, it's 4, and if I square negative 3x, it'll be 9x squared. That would be incorrect because that is not, this is like, I'll show you why that doesn't work out here in just a second. So let's deal with the easiest part. Is the numerator or the denominator easier to square?
Easy squared.
Easy squared?
No, you said it's easy squared.
Denominator is easier to square. What is the denominator when we square it? 25. Okay, so now we are going to square the numerator. Now I'm going to do this work off to the side here. We're going to do 2 minus 3x squared, which is the exact same thing as 2 minus 3x times 2 minus 3x. Now, knowing that, what am I going to do with FOIL them? So this is going to be more, sorry, I'm trying to color code this. That's the wrong color.
There's not a faster way to do it. You have to do foiling.
I eventually teach people a trick to get through those faster, but I can tell you right now, and I mean this out of love, that you guys aren't ready for it yet. Like, it's going to be, you'll be more lost than you were in the first place. You'll get there eventually, and when we get there, I will show you the trick that you go, oh, we could have done that the whole time. And the answer is yes, but we're missing some things to be able to do that every single time. Okay, so what are we going to multiply first?
2 and 2.
2 times 2 is 4. Now, outer times outer.
6x. Minus 6x.
Negative 6x. Inner times inner.
Minus 6x.
And then last times last.
Plus 9x. Now,
Something's wrong.
what's wrong?
One of those terms is wrong. What's wrong with the last one?
Square 9x.
Mm-hmm. Positive 9x squared. Negative 3x times negative 3x is a positive 9x squared. Okay, but something can be combined here, right?
Yeah.
4 minus 12x plus 9x squared.
The negative 6x and a negative 6x can be combined together.
To become what?
12x
Like that?
squared.
Square?
No. It's only when you multiply, right?
I need some help. There's like 20 of us in here. What is this? Negative 6x minus negative 6x.
Negative.
If you have negative 6 minus 6, that's a negative 12x. Plus 9x squared, and we have a 4 up front. So 4. Now, I'm going to put all that in the numerator. But we learned about the proper way to write 3 terms like that in standard form.
Ooh, 9x squared minus 12x minus 4.
Plus 4.
because that's a positive 4. So I'm going to write that in the numerator. We get 9x squared minus 12x plus 4. And I'm about to ask the question that somebody in this room is about to ask me. So wait, so that's the answer? Yes, that is the answer. Because I can't divide each one of those things by 25. Like, think of like what goes into 25, like 5 and 5, or 25, and they don't all share anything in common that I could divide them by. Like, I would need to divide 25 by the same number as 9 and 12. There's no common factor that I can divide them by. Yes, ma'am?
Okay, wouldn't it be negative 25? Because a negative 5 times... Oh, no, never mind.
Glad I could help.
Wait, no, wait.
Finish your sentence. You are about to come to the same conclusion. Finish what you're about to say.
Negative 5 times negative 5.
Which is?
Positive 20.
Beautiful. I knew you would get there. Somebody else had a question? No? All right, let's stop there. And that is all you need to get through 16 of your homework. What? Yeah, you may have to factor. That's